Okay, so in this example, I'm going to solve the inequality x squared minus 14x less than negative 45. This is an example of a quadratic inequality. So this example will lead us to hopefully the understanding of how any quadratic inequality is solved. So the first thing to understand is that what we're dealing with would be a lot easier to understand if we understand what we call the graph of a quadratic. So I'm going to go to a new board and hopefully this makes a lot of sense. So I'm going to draw very schematically what a quadratic equation looks like. So the graph of a quadratic gives you a parabola, right? So the parabola, say, can look something like this, right? And the quadratic was going to have a few features, the vertex and the x-intercepts and so on. For now, all we care about is, I'm going to say the question says something like a parabola, I'm writing the p for the parabola, is less than 0. So what this means is, to solve an inequality of this form, it means what part of the graph is under the y-axis, sorry, under the x-axis. So in my example, which is very simple, it's just that we're talking about this part of the parabola is less than 0, right? So the solution is all numbers, the x values between those two numbers, these two. This is the solution for what numbers is a parabola less than 0. If, on the other hand, we were asked to find where is the parabola greater than 0, then we'll be looking at these parts of the parabola. So the answer is for these values of x over here, those will solve this. So there'll be these two parts will be solving that inequality. So in any case, the big point here is to realize that all we need to do is find these 2 points, the points where exactly the parabola crosses the x-axis. These are the important points. Okay. Once you found these 2 points, which are called the x-intercepts, I don't know if you can see this purple thing, it's very weird. Very bad selection of colors. Once we find these 2 x-intercepts, then all we have to do is decide, well, my solution is going to be either between the 2 x-intercepts in this case, or outside of the 2 x-intercepts in this case. So if you understand this big idea, so our goal is to understand where is the parabola above the x-axis or below the x-axis, depending on the question. To do that, you really need to solve where is the parabola equal to 0, which means it lies on the x-axis. And from there, go and say, well, where is it above and where is it below? For that reason, the book says, well, just take any point over here, for example, and if you get a number above, it will always be this part. You're looking at the part that's above the x-axis. If you pick a number between the 2 here and you get a negative, oops, I don't know what happened, and you get a negative, then you know that any number between them is below the x-axis. So that's the big idea, that they use these test points to decide if it's above or below. Now, with parabolas, it's pretty simple. You probably don't have to use the test points because it's so simple. You know, if the parabola is opening up, between the 2 x-intercepts it's below the x-axis, and outside it's above the x-axis. If the parabola is, on the other hand, opening down, like we know that we experienced by inertia, know that there's also parabolas that look like this. In which case, if you find the 2 x-intercepts, then anything between them will be above the x-axis, and everything outside of them will be below the x-axis. So you can use that common sense as well, and not use any test points if you know that the direction of the parabola determines this. So okay, let me go and see if this idea makes sense with our example. So I want to solve this inequality. So I'm looking at a parabola. Which parabola it doesn't look exactly like a parabola right now because you have less than a number, the negative 45, which looks pretty ugly. But every time you do with a quadratic equation, just like you did in your previous class, what you really want to do is change it to make it look like a quadratic equation, in this case a quadratic inequality, that is really, with a 0 on the other side. So have less than 0. So I changed that one, and then we'll deal with this one now. It is the same inequality. So the solution said I'm looking for the original one is the same as this one. I added 45 to both sides. So now I'm looking, okay, so for this problem, I'm looking where is it below the x-axis. Now, I don't solve this as an inequality. Like I said before, what we do is we really change the question and say, I'm going to now look at the equation. Where is this equal to 0? Forget about the inequality part. I know I have a less than sign, but it doesn't matter. I'm going to look where is this one equal to 0. Okay, why? Because if I know where it's equal to 0, then I just decide if I'm looking for the part below the x-axis because I have this sign right there. Okay. So where is this equal to 0? Well, I can factor this one. It becomes x minus 9. Oops. X minus 5. That tells me that this equation is equal to 0 at x equals 9 or x equals 5, right? What I'm doing is using the 0 product property. That means that either if this times that is 0, either this is 0, which gives you x equals 9, or this is 0, which means x equals 5. Okay, so now I'm done. I'm in the case I talk in the other board. If I have this in a parabola, I don't have to do a careful graph. I know it looks something like this. Oops, sorry, let me back. I know it looks something like that. Where this number right here is a 5, and this number right here is a 9. Right? So I'm looking for where is this less than 0. So what the book does is goes and say, check some test points. Check a number on this side of 5. You could use any number on this side of the 5, on the left side of the 5, to check. Here, like -2, or 0, or 4, or 1. Any number here, you plug it in to this function, or sorry, to this equation, and you get something positive for sure. If you plug a number between the 5 and the 9, you get something negative. And if you get something on this side of the 9, you get something positive again. So that's the test points that the book uses, and maybe that's confusing to some students. But what you're really looking at is a graph. So I know, for instance, because I know this problem opens up, that it's a number between the two numbers. So my solution, where is this less than 0? My solution is between the 5 and the 9 as an interval, or you can write x is between 9 and 5 as in interval notation or in set notation. Okay, or in inequality notation. So hopefully that makes sense. So when I got a lot of questions asking where are these numbers coming from, the test points. Well, like I said, here you really don't have to use the test points if it's confusing. All you're doing is checking on the left of 5, are you above or below the x-axis? Between the two numbers, are you above or below? You know if it's above here, it's going to be below here, so it's not a big deal. In the next section or chapter, we're going to deal the same idea with a polynomial, which is going to be something like this. And the idea is going to be very similar, and there you might need to do some test points, or depending how comfortable you are with the graphs. It's the same idea. You're going to find the x-intercepts and then decide between the values, is it above or below the x-axis. Okay? So that's what we're going to. So I hope this makes sense. And that's what the idea is about solving these quadratic inequalities.